So the next thing I'm going to do is writing some code, and that code is going to be based on this modified version of uh, assignment 3, right? So here you can see we have some sort of camera control. This is a cube. So if I go closer to the cube, as you can see, and then I can do some sort of panning around the cube, then we have a better side of the cube. So this is the side of the cube, right? And I can do some sort of first person view walking here using my keyboard to see different side of the cube. So what I am exactly visualizing here is the locations or the vertex positions of the cube. So let's go back to the code. So the HTML file is similar, and we have this camera class, which is pretty much similar to what we did for our last assignment. And then we have some models. We have a cube. I removed the I'm going to talk about the cube. Like the model is similar to, this is the generic model that is going to be inherited by all the models like cube, sphere. I removed the 2D model. Like last time we had a triangle, but the triangle is not going to be helpful at all for the light model. So I removed that, left the cube here. I'm going to talk about the modified version of the cube in a bit, but let's go to the assignment 4. So this is pretty much what we had last time, right? So we have this model matrix, view matrix, projection matrix. We don't need that yet. So we don't need that yet. Also, so this is good enough to see what we want to see. So we are just calculating the GL position in the vertex shader and the color. So the thing about the color is I assign the position in the color. That's why we look like this colorful changes in the cube. But I can just use the uniform color. So we created this varying color. Instead of doing that, let's use the color we're passing from our JavaScript. So if I use the U color, and I actually assigned a color when I created the cube here. So yeah, so this is the place where I created the cube. So I assigned the color blue, and you'll see this is going to be a blue cube, right? So this looks like a 2D object, but still, if I do the FPS walking around it, you'll see this is a cube. So we have some sort of camera control. We have a zoom in out. So this works for a cube, and from there we're going to continue. Okay. So if I go back to the cube, okay, before that, let me create a new file and call it topics.txt. There we go. And what we're going to discuss here. So let's go back to the assignment. So we are going to discuss, we already have a cube. We're going to add a sphere. Then we are going to do, we're going to calculate the light, right? So we are going to add a light. But before that, we need to calculate normals. Or let's say add. Then we're going to add the light position. Then we're going to add shading model. Form is one option. Another option is using the block shading. or per vertex. You'll see only one. Spheres and sphere. Okay. Then next thing is add a point light. I believe these are the things we want to do today. Okay, so the first thing we want to add a sphere. Before that, I'm going to show what changes I made to the cube. So as you can see, this cube is sort of different from what we had last week. So last time, in the assignment 3, the cube we had was here in geometry. So this cube had all the vertices. This is pretty much the same. You can see only the vertices. So we had these vertices, and then we had the color. Then we had the then we had the EV coordinate systems, right? This was the plain version. So this time, if we go to the new cube here, you see now we sort of separated the vertices, and we have something called the indices, right? So the indices are here because when we are okay. So this is our draw model function. Everything is same except now we have this call, which is draw element. And in the assignment 3, we had this call that was separate. So yeah, the assignment 3, when we did the draw call, so these are all the attributes we used. Then this was the draw call, right? So the draw call was draw array, not draw element like this time. So what is the difference between the draw array and draw element? So you can see that in the draw array, we are still drawing the triangle, then we are just telling the function where are the vertices and how many vertices we're going to use and the length and other stuff. For the draw element, we have a different data structure which is called indices. So the indices are actually, we're saying which vertex is creating which face. For example, the front face is created by 2 triangles, right? So the first triangle is using the first vertex, second vertex, and the third vertex, right? So this one, and this one. This 3 is going to create the first triangle. As you can see, V0, V1, V2. And then the second triangle in the front face is going to use the 0, 2, and 3. So this is 0, this is 2, and this is 3. So these 3, they are the front face of the cube we have here. So this time we sort of redefined the cube structure. We are only going to use the draw element and telling the draw element the indices, providing the draw element function the indices, and it will draw the whole object, whole cube. So this is easier because we are going to calculate the sphere and its indices, and we'll have more components here. Like we'll have a normal matrix, not a normal array, and that array will be passed to a normal matrix, right? So handling all this separate component is easier if they're separate arrays instead of the same one like the last time we did. So to understand more about this draw element function, I refer to the book example. And actually, we're going to use a lot of the resources from the book So okay, so where did I get these coordinates and these indices? Did I calculate those all? Yes, sure, you can do that, but I sort of use the book for the resources. So let's see, there should be a hello cube or something. Yeah, so here is this hello cube example. This is pretty much looks similar to what I did in my code. So the assignment 4, if I assign the V colors here, it will look like that cube, right? Yeah, not exactly the same, but sort of similar. So let's go to that side and then so this cube, if I check the code, if I see the page source, you'll see they already calculated the coordinates and the faces of the cube. So I sort of used the same coordinates, the one they have here, copied that, and then used that data here to calculate to use the coordinate to draw the cube, right? So the book examples are going to be useful for our sphere drawing, because I'll show how you can do that easily. And so the thing about the cube is we don't have any lighting here, right? This is just a colored cube. If we check the other book example, there is a colored cube that is, let's say this one. So this is a single color cube, which is more like the cube we originally showed here. If we use the U color instead of white, we are using blue. So this cube is similar to that cube, right? Except I don't want to use white. That is too blank. So if I go to that cube and check the source, you'll see they're sort of using the same type of structure, except now they have a color array. I'm not going to use color array. I'm just going to use this. But eventually, what we're going to do, we're going to need a normal array here, right? For the cube, I said we're going to calculate the normals. So just to show you the structure, we can add that here, right? So where do we get the normals? That is also where I'm going to take help from the book. So the book has chapter 7, mostly discussing about the lighting. Chapter 8, actually, lighting object. So there is a lighted cube, which is another example, except now they have this red cube with lightings. Why don't we make this one red as well? So yeah, so if I make the cube red, probably it will look closer to the one in the book. But we don't have the lighting because we also don't have the normal. So the normal of the cube is also given here. So now they have this extra array that is called normal. I'm going to copy the whole thing, just like I copied the vertices here, and I'm going to use it for our cube. We'll use that later, but for now, I'm just going to create the normal array. Okay. And we need this to make sure that the normals, they're part of the class, right? So we have these normals, and then we have this explanation of how the vertices are working. So we have these vertices, we have this normal, we have these indices. We are not yet using the normal. So if I refresh this, nothing will change, right? Only thing, I use the lighted cube normals. Okay. So how exactly the normals are working here? So let me quickly draw something here. So for WebGL, for example, for this cube, we actually are drawing the cube like this. Okay. So if this is the cube, then this is a rough drawing. So we have some triangles here, right? And for each point, for each vertex, we have three normals. Like one is in this direction for this triangle, one in this direction for the triangle on the other side, and we also have a triangle here. We have one here. So we have a normal here, right? So this, all these normals we can calculate from the cross product of this vector and this vector. And for this one, we can do that from the cross product of this vector and this vector, right? So probably I should have used a different color for the normals. So these are the normals. So that is exactly how they calculated the normals in the book, as you can see. So for these three, we have one normal here. So the normals are calculated per vertex, right? For each of the vertex, there is a normal that is calculated. So, and then that means for each face, like this is the front face, we have four vertices, and for each vertices, we have normals here. And interesting thing is, let me clear this. For example, this is V0, this is also V0, this is also V0. So for V0, we have three normals, right? And how is that? That is sort of from this drawing, you can see. For this, if this is V0, we have three normals for V0, depending on which phase we are using. So the calculation is, if you do like cross products, you'll see you can match your calculation with these values. I believe from assignment 0, we already know how to do the cross products. So if you manually want to calculate the normals for your object, which is, at least for cube, I don't see the need for that. For the sphere, we're going to eventually need how to draw the object. Okay, then we are good with the cube. But now what I'm going to do, I'm going to go to their point lighted sphere here. And based on their sphere, I'm going to draw this. I'm going to add the sphere, which is our first requirement, right? So we're going to add sphere here in our scenario, in our scene. So how do we do that? So let's go to, okay, let's create a new file here and call it sphere .js, right? And the sphere.js is going to be pretty much same as the cube. So I'm going to copy everything here. And then it's not going to obviously going to be the cube, it's going to be sphere. And we need the color. We are going to have our coordinates calculated differently, separately, right? So I can remove everything. And then We will calculate our normals, we will calculate our indices. And how is that going to be? Okay, so how exactly can you draw a sphere, right? How this sphere is being drawn? So this sphere is actually, if you go to the code and see, this is the place where they're calculating the sphere, and as you can see, they're calculating the positions and the indices. So the sphere is more like drawing a 3D circle, right? And for the 3D circle, you have locations, like you can almost see the triangles here, right? And it would be easier if I could change the codes, but at least this is per vertex, so the triangles are mostly visible. So if we go back here, and now, so we're in the wrong assignment. Okay, in the models, we are going to modify this to make our sphere all the vertices, the indices, and the normal. Okay, so the calculation of the vertices, they are going to be, we can decide how many divisions we are going to have for the spheres. That is more like a circle. Let me draw here. So this can be a circle, right? So how we can define this circle? So we can define how many divisions we are going to have. Like it can be something like a hexagon, right? That is also a very rough circle. So this looks sort of like a circle, but how many divisions do we have here? 1, 2, 3, 4, 5, 6, 7, 8. So this is an octagon, right? Hexagon would be two cores. So if we add more divisions, like we subdivide each of the lines, eventually this would look like a circle. So instead of 8, if we have like 16 divisions, it looks better as a circle, right? So now these divisions are going to be also applicable for the sphere. So the sphere is more like this globe, right, where we have this is not very good example. Let me draw the 2D circle first. Then these are more like the subdivisions, right? So we'll have small faces that will create the sphere, and then each of the faces will have a triangle. We'll have 2 triangles, right? Because each of the rectangles, they have the triangles here. That's the wrong direction, like this. So this is exactly what you can see here. This is more like the triangles they have here. So now, since we have that, now we're also going to need the light. So for the light, we're going to need to calculate the normals. So how the normals are going to be? They're going to be per vertex, right? We can have per face normals, like how the light is going to be reflected here or here. But instead of doing that, we're going to do the normals per vertex. And this is similarly, for example, this vertex, the normal is going to be the cross product of these 2 vectors, right? And this is going to be the normal. Okay, so the interesting thing about the normal, for example, if this is a circle, we have a normal here, maybe we have a normal here, the circle, but let's say this is a sphere. So let's say we have these normals all around the sphere. So how do we calculate each of the normal? So in fact, the normal is a vector from the center. So if this is our center, so if we draw a vector from the center to the vertex point, so if this is our vertex, what is normal in this vertex? So if we connect the center and the vertex and draw a vector, this vector is also the normal, right? That is true for even this vertex. So for all the vertex, the location of the vertex, the position of the vertex is also, if we draw a vector from the center, this is also the normal. So in fact, we can use all the vertex as the normal, right? This is applicable only for the sphere, not only for the sphere, maybe a few more objects, but actually we can use this advantage to go on without calculating the normals, right? So that's exactly what you can do. And that is exactly what the book is doing. So the book has the positions. So the positions are vertices. And you see when they are passing the values to position and to the normal, they're using the same values for the normal and for the positions. So when you're calculating the coordinates, the positions, you get the normal calculation sort of for free, right? So the generate coordinates and the generate indices, this is explained more in the book. So what I am going to do, I'm going to use exactly what they are doing in our code to generate the indices and the vertices, right? So okay, let's keep this page open and then let's work on our sphere. So this is our sphere. We have this constructor which has color and we can define how many divisions we're going to have in our sphere, which is defined here. Then we can pass that as a parameter, but for simplicity, let's not do that for now. So I'll hard code the value of the division. So let me have some vertices, and then instead of doing this, what I'm going to do, I'm going to create a function. That function will create our vertices, right? And that function is going to use the one from the book. So instead of having this new float array, we are going to we need this. We need indices and we need normals. Then so the normals are going to be exactly same as the vertices. So we are going to use this for our normals and also for our vertices. So I'm going to put the values that I'm going to calculate from the create vertices function here. And then so why I'm using this, why I'm doing this. So in the book example, if we go back, you'll see when we're pushing the values, they are not exactly going to be float 32 array. So they are doing is casting here just to change the positions to float 32 array. Because when we're passing them to the shader, we need this format. The default format is not going to be a match, right? So instead of doing this casting, what I can do, or what we already did, we already are doing this casting here, and the calculation is done here. So we have this create vertices. Also, we need to create the indices, right? So the indices is blank now. So create indices, which is also part of the book. So generate coordinates, generate indices. So this part we are going to copy exactly from the book. So let's do that. Copy the whole thing. And put it here. And then we're going to make some changes. That is fine. Okay. So we have these positions, but we don't have positions as a variable, right? So we need a variable similar to what they do in the book. So we need this, we need the positions, and we need indices. So let me copy and paste. And then this is going to be needed for this one. Okay, then we need this sphere division, right? So this division is something we are going to pass along to the function. So we need to settle with some division value. So let's see what division value the book is using. So they're using 13. Well, let's use 16. 13 would be too coarse, I'd say. Okay. So for create vertices, I'm going to hard code this value here. I'm going to pass 16, and then I'm going to use that vertices for vertices and the normal. Okay. I believe we have everything here. Nothing is probably missing. Okay. Now we need to use this create indices function, right? So we can have indices. Okay. It's not exactly good to use the same variables here. So let me okay, I'm going to go with this different variable name just to avoid any potential conflict with this local variables. So indices 1 is going to be this function. Yeah, 6. Let's use something separate. So I'm going to call this n, and 16. Also going to use n here. Okay. Are we done? I don't think we are done. So we are calling the functions. We're expecting to get vertices 1, indices 1, and I want to use this indices 1 for this one. And but I never returned anything in the function, right? So I need to return something. So for this case, I need to return the positions. And here I need to return So this is that, this is that, this is that. Okay. So this is where our function is ending. So I want to return indices. Okay, so hopefully we are good. Everything is good so far. We have these vertices, we have the normals, we have the indices. Actually, let me remove the normal from here. Here. Because the normals are less necessary. Of course, they're necessary, but normals comes after the indices. So the first thing is generate the vertices, then generate the indices. These are the two things we need to create a sphere. Okay. So nothing will be visible here for now. Then our first objective is not done yet. We still need to draw some sphere on the screen. We have a cube. We have to draw the sphere. Okay. Okay. So first thing, we need to add it here, right? We need to import the sphere. So I'm going to add that here. Sphere.js, saving, and then refreshing just to see what I have so far. I think I can safely close this. I will open this if needed anytime soon. Okay, so in the place where I have this cube, I want to create some sphere, right? So let's copy this exact part. So we have this add model function created here that is creating the sphere or the cube. So we need another case here for the sphere. So let me copy the whole thing. This is sphere, add model, and then I want to create a sphere. Right? Error so far. Then I want to add the sphere here. So let me translate the cube a bit to give the sphere some space. So let me push it below, maybe 0.5 minus. Let me push it a little bit more. That can be 1.0. Yeah, you can see the look. It looks like I can see the top of the cube. I want to draw the sphere on the top of the cube here. So I am going to copy the exact same thing and see if we can make it work. I'm getting a lot of bugs, that is common. But if you're lucky, it may work in the first try. So let me push the sphere a little bit up and see what kind of error we're going to get. Okay. So create vertices is not defined. Let's go back to the sphere. So create vertices is not defined. Why it is not defined? Let's see. Okay, yeah. This is part of the class, right? So j is not defined, yj is not defined. So this is the j, right? So let me define the j. So let j and let I. Anything else is not defined? Yeah, I think none of these are defined. So I copied from the book. Maybe they defined it before. Yeah, none of these are defined. Not defined, not defined. D1 is defined. I don't think so. Not defined, not defined. Let's see what else is not defined. Oh, wow. That's interesting. Did I push the... So this is the sphere. The cube should be pushed down. The sphere should be pushed up. Why is the flip? It's the opposite. So cube is cube, sphere is sphere. All right, I did the opposite, I think. Or not. Let me disable the cube for now. Only have the sphere. And the cube is not defined. And where is that? Line 205. Oh, okay. Now I see what was happening. Yeah. I never change these things, these variables. Yeah, now what I wanted to do is here. So let me disable the cube for now. Or I can keep it, that doesn't matter, right? And what I did is the same color. So for the sphere, let's use the red. For the cube, let's use the blue. So that we see that we have two separate entities, right? And if I zoom in, something like that, you can see it from the other side. You can see it, right? So we successfully created this sphere and this cube. And we don't have any lighting on it, so it looks like a flat surface. So that's the next thing we need to do. But at least we are done with these two things. We are not quite done with the normals. That is the next thing. We have just calculated the normals. So the next thing is adding the normal to the JavaScript side.